Easterbrook this afternoon, and she's going to be talking about Britain in the last ice age. So put your hands together for our guest speaker, geologist Glynda Easterbrook. Thank you very much.
Good afternoon, everybody. Welcome back to all those who were with me on the last cruise, and very, very welcome to those who've joined this cruise. I hope to entertain you in the next 45 minutes, talking about the most recent part of geological history, which is from now back to about 2.5 million years ago. And welcome also to people who are watching in the cabin. So I'll make a start. Anyone who's wondering what that picture is, it's actually a reconstruction of the wildlife and the Paleolithic communities that lived near Kent's Cavern, but that is during the last ice age. Now, currently, about 10% of the Earth's surface is covered by ice. Most of it is at the polar regions, at the North and South Poles, but there obviously are some areas where there is ice on high mountain ranges. But the majority of the ice is concentrated around the polar regions, which of course are the coldest parts of the Earth. But 450,000 years ago, during a period known as the last ice age, this is what the Earth looked like. You can see that there was far more ice over the northern and southern parts of the world. The ice extended right down over most of northern Europe and also most of the British Isles. And this is what I'm going to be talking about and will probably be of most interest to you, to see what the effect of that ice was during that time. And of course, because water is locked up in the ice sheets, sea levels were much lower. And that features quite a bit throughout this talk. But it's not just what the last ice age is, just one period when the climate was much colder. If we look back through the geological column for the last roughly 540 million years ago, you can see from this graph that there are times when the world has been in what we call an ice house condition. That is when temperatures were lower than they are today, and they are indicated in blue. So if you look at the wiggly red line, you can see that certainly at the moment, right at the top, that's where we are. We're in the middle of an ice age. We are still in an ice age, but we're not frozen over like we were during the last glaciation, and I hope that will become a lot clearer as the talk goes on. But there have been times further back where there have been great big ice ages during the Permian and the Carboniferous, but there have also been times when the Earth's average temperature was much warmer than it is today. And during the Cretaceous, which is up the top there, that was the period when the dinosaurs were living on the Earth. During the Cretaceous, the Earth was much warmer and there was no ice at all on the Earth's surface. So it was what we call a greenhouse condition, greenhouse world. And this is probably the most complicated graph you're going to see throughout the whole of this talk, so don't be worried. But this graph shows what's happened to the average global temperature during the last million years. And if you look at the blue line, you can see that it wiggles up and down, up and down. There are big peaks and big troughs, and then there are lots of little wiggles in between. And the graph shows at the bottom that there are three major periods of cold temperatures. These are the three glaciations which we know to have affected the British Isles. But in between there are periods where the average temperature was actually higher than it is today. Today's temperature is marked at the top in that dashed line. but there are some times when the Earth's temperature was higher. These are known as interglacials. So the red area indicates interglacials, warmer periods, and the blue area is colder periods or glacials. And Britain has been affected by three major ice advances. The oldest one is the one at the bottom marked in orange. That's known as the Anglian glaciation, and that's the time when the ice extended furthest south in the British Isles. And during that Anglian glaciation, you can see that all of Scotland, north of England, Wales, nearly all of Wales, and down as far as East Anglia was covered by a thick ice sheet. And this thick ice sheet in Scotland was 2 or 3 kilometres thick, so it really was a thick ice sheet. And the only area of Britain that escaped the ice itself is southern Britain and small parts of Wales there, and Ireland, unfortunately, is off the map, but the southern bits of Ireland also just about managed to escape the ice. But of course it was still on the edge of the ice sheet, so it was very, very tundra-like in its appearance. So there was permafrost and it was still cold. So this is what Europe looked like during that Anglian glaciation 450,000 years ago. And there you can see Britain, the southern bit of Britain, just poking out from underneath the edge of that big ice sheet. And as I said before, sea levels were much lower. The sea level was probably about 100 or 120 metres lower than it is today, because the ice was the seawater was taken up in that big ice sheet. This was the last glaciation to affect Britain. So I said there were three. There was the first one, which was the Anglian glaciation, and this was the last one, known as the Devensian. And this happened only about 18,000 years ago, so really recently in geological terms. The map shows the extent of the Devensian glaciation. It didn't extend as far down as that Anglian glaciation, which is the one marked with the red arrow, but it still came down quite a lot into Wales and northern England, and it covered all of Scotland. And I said that was the last glaciation. That was the real last advance of the major ice sheet. But after that, about 14,000 years ago, that major ice sheet started to retreat and melt. But there was a small advance of it about 13,000 years ago, known as the Loch Lomond advance, and it only affected Scotland and a little bit of Cumbria. And so that blue area marked on the map there, that's where the ice sheet collected, or it covered that area of Scotland, and there's a little blue patch down in Cumbria as well. And the rest of Scotland, the areas marked by the little black triangles, they're a bit too small to see, but those little black triangles are where they've found frost wedges or ice wedges, which indicates tundra-like conditions. And it's actually this Loch Lomond ice advance that's responsible for a lot of the features that we do see in Scotland today. And one of these features that was caused by that Loch Lomond ice advance, I don't know if you've ever been to the parallel roads of Glenroy in Scotland. They are three very distinct stripes that go across the hillsides like that. They're not roads, they look like roads, but they're not. They are actually the sites of, there was a big glacial lake here during that Loch Lomond ice advance. There was a big glacial lake that was blocked by ice that was coming down from another valley. And these three lines represent the shorelines of that glacial lake as it melted further and further down the valley. And this is what the Lake District looked like 13,000 years ago. A lot of the features in the Lake District, the lovely lakes, Derwentwater, Ullswater, etc., had already been formed much earlier, during the earlier ice stages of glaciation. But ice was collected on top of some of the highest peaks in the Lake District, like Scafell Pike and High Street. And I mentioned, when I showed that rather complicated graph with the blue line, I said there were some big wiggles and some smaller wiggles. The cause of major ice ages is there are many causes for ice ages. It can include huge amounts of volcanic activity, whether there's volcanic activity, whether the distribution of the continents around the globe throughout geological time. If you have large land masses, that can actually mean that all the seawater surrounding that large mass it's not able to interact with the land as it does today. And the little wiggles between the glacial periods, the little wiggles are due to the Earth's movement orbit around the sun. So the Earth's orbit is not a circular orbit, it's actually an elliptical orbit. So there are times during the Earth's orbit when the Earth is closer to the sun than it is at other times. And obviously, if it's closer to the sun, it's going to be the climate's going to be warmer. And when it's furthest away, it's going to be cold. And as well as just that singular orbit, the Earth also revolves around an axis that's not vertical, and so it wobbles around a bit, and that also can affect how close areas of the Earth are to the sun. And we know that we have the seasons, and the seasons are the result of that wobble, but that can also affect the overall global temperature in geological time. And this is a little animation that I think is really good. This shows what Europe looked like 37,000 years ago. This was during an interglacial. This is when there was very little ice. There was some ice in Scandinavia, but Britain is there somewhere. Yes, there it is. Britain is there on the far left. It's a bit hard to see because it's actually part of Europe. So during this time, during this interglacial, when the sea level was much lower, Britain was joined to Europe. I'm going to start the animation, and you'll see that it's coming forward to about 8,000 years ago. And during that time, I'm hoping that you'll see that from this animation that the ice, it's advanced, it's gone back, it's advanced, it's gone back, and also the sea level changes as well. So the sea is marked in blue, and as we get towards about 10,000 years ago, you'll see that the sea suddenly comes in, goes into the English Channel, and Britain is finally cut off from Europe. So I'll start it here. Let's hope this goes. There you go. So you can see it's coming and going, especially in Scotland. Britain is now being affected quite badly. Then it retreats again and it advances again. So it will soon disappear altogether from Britain, but it comes back quickly, just briefly for that Loch Lomond advance. There it is. And then it disappears, and all the ice is melting. And then look what's happening to the sea level. And there we have Britain is now cut off from Europe. And so, what was Britain like during that ice age, or those ice ages? Well, it probably looks something like this. This is Antarctica. There are peaks of rock, mountains sticking out from the top of the ice sheet. If it was a very thick ice sheet, there may not have been any land poking out at all. And this is a diagram of the sort of thing that you see if in geography textbooks. If you've been interested in geomorphology in the past when you were at school, you would have seen these diagrams showing what happens when the ice collects as glaciers in valleys. And it forms the erosion of that ice forms various physical features in mountainous areas, such as these sort of very sharp knife-like edges called arêtes. And they're formed when you have two glaciers in adjacent valleys plucking away at the rocks, leaving behind a very, very sharp knife edge, such as here in Helvellyn in the Lake District. And here's another one in Snowdonia. Snowdonia is another area where the landscape is very much influenced by that ice. And as well as arêtes, those sharp edges, you also find where you have accumulations of ice in basin-like features at the heads of valleys, you'll get what's called a suic, or sometimes it's called a cum, or in Scotland it's called a corrie. And the ice collects in those basin-like areas, and over time it erodes the rock away, and all you're left with is a saucer-shaped depression, sometimes filled with a glacial lake or a tarn like this one here in Snowdonia. And the main erosive effect of the ice is what's known as freeze-thaw action. And all it is, it's when you have an area of high ground that's covered by ice. If the ice melts for any reason, it can melt on a daily basis with the sunshine of the daytime. If the temperature heats up sufficiently to melt some of the ice will turn into water. It will go into cracks in the rocks. Then if it becomes cold again, it will freeze, and that action is sufficient. That freezing action is sufficient to split those rocks along little cracks and fractures that might be inherent in the rocks. And so over hundreds, thousands of years, eventually the rock will be broken down like this. And so these two rocks show that action very well. The ice goes into little pre-existing cracks or veins of minerals or fractures, and eventually it will break the rock down into very, very sharp angular pieces, which will build up on the sides of the mountains as scree slopes, such as here. And that rock becomes caught up in the glaciers. The glaciers, as you know, glaciers, they do move. They will flow downwards very slowly, flow downhill. And as they do so, they'll pluck bits of rock from the sides of the mountains or the valleys. And those bits of rock become entrenched in the glaciers as moraine. And this diagram shows a medial moraine, which is moraine that's in the centre of the glacier, but moraine can be caught up at the edges of the glacier. It can also make its way down to the bottom of the glacier. So there we are, that's the medial moraine. And there's a nice picture showing that effect. I think that's in the Alps, but wherever you go, if you've ever been to Norway or anywhere where there is a glacier, if you can get up high enough, you can see evidence of these moraines. And once the ice has got those sharp blocks of rock entrenched in it, it acts a bit like sandpaper. So as the glacier is moving downhill, it's scraping away at the valley sides, and it forms these very, very typical U-shaped valleys. Now, a river makes a valley that's a V shape, but a U-shaped valley is the result of ice. So whenever you see a lovely U-shaped valley like this one, this is Glencoe, you know that there's been the action of ice. And sometimes these valleys get filled with water, and then they become lochs, or if they're open to the sea, they will form fjords. There's another really nice U-shaped valley in the Lake District. There's a road that runs down through the middle, but sometimes these U-shaped valleys have streams in them as well, modern rivers or streams, but the main erosion that's caused those valleys is the glaciers. And some of that moraine, if it gets to the base of the glacier, it acts like sandpaper. It scratches the rock over which it's passing. And so you'll get these lovely striations or stripes. And they're quite useful for geologists because they show us the way in which the ice was moving. So wherever you've had ice, be it in Iceland or in Norway, if we see those striations, we can tell which way the ice was moving. And as I said, if those U-shaped valleys get filled with water, they'll form lochs. This is a nice picture of Loch Lomond. And Loch Ness is a similar loch. It has the same method of formation. But Loch Ness is interesting because it actually runs down what is a pre-existing geological fault or a big crack in that part of Scotland called the Great Glen Fault. So the ice in that instance preferentially eroded along that fault to form the magnificent Loch Ness. So those features are what we'd call erosional features. They're the result of the ice scraping away the existing landscape and affecting it in that way. But as the ice melts and retreats, all of that moraine that it had caught up in it gets dropped or dumped at the edge of the glacier. And this is a picture of a retreating glacier, and all this grey material at the front and the lakes. That's all moraine that has been left behind by that retreating ice. And this is a picture of a subglacial moraine, which is in an ice cave at the edge. If you go to a glacier, sometimes you can see these ice caves, and underneath the ice there's water coming out. These are subglacial streams, and they bring all that moraine out from the base of the glacier. And this is what it looks like. If you've ever been to the fjords, you'll have walked over loads of this stuff. Glacial till or boulder clay, it's sometimes called boulder clay because it's a mixture of boulders, all very poorly sorted, big boulders, pebbles, angular blocks, clays and sands, so completely unsorted material. And it's all material that's been plucked off the sides of the highland areas over which the glaciers have flowed. And we have some fine examples of glacial till in Britain. If you live on the north coast, or if also in East Anglia, a lot of the topsoil and along the cliffs of those areas is made of boulder clay. And it's, as you can see, it's very soft, it collapses very easily, it's very easily eroded away by the sea. Such as here in Norfolk, a lot of those cliff collapses are due to the fact that the overlying boulder clay, which sits on top of pre-existing rocks in most cases, but it's eroded away, it will collapse and needs coastal defences to stop it from being eroded further back. And underneath a glacier, sometimes that moraine, if that moraine has got a lot of clay in it, the glacier moving across the top of that clay will form these sort of mounds. It moulds the clay into these strange elongate shapes, or drumlins as they're called. Drumlins are quite useful because they too can show the direction that the ice has moved. So they're rather bulbous in shape. They look rather like a teardrop, and the bulbous end is downstream of the direction of movement of the ice. So geologists can use aerial photographs to work out the ways in which the various glaciers have moved with time. And there's a nice picture. I'll just adjust that. It's a nice picture of a drumlin field in the Lake District. Sometimes it's called basket of eggs topography because it look from an aerial view, it looks like a load of eggs. It's egg-shaped structures. Also, glaciers are actually capable of carrying huge blocks of rock, great distances. Many of the glaciers that came across Britain originated the ice as they've brought blocks of rock from Scandinavia or from other parts of Scotland, and they can dump those blocks of rock anywhere. But of course we can recognise them because the rock itself is a foreign body. It doesn't live. It's not now in the place where it was formed. And there are some good examples of this in the Yorkshire Dales in Yorkshire, known as the Norber erratics. And this is a really nice one because it shows a big block of some grit or sandstone that doesn't belong there. It's come from much further away, and it's sitting on top of limestone, which is the rock that's found there. And it's formed a protective little cap over the limestone. So all around that erratic, the limestone has worn down, but it's been protected underneath the erratic, and so it sits like looks like a little mushroom. And again, we can use erratics, we can look at the rocks in the erratics to work out where the ice may have come from. So if we find an erratic, which is a rock that's derived from Scandinavia, we know that the glacier must have come from that direction. So during a glaciation, any one of those glaciations, most of Britain and northern Europe was covered by an ice sheet. Sea levels were about 100 to 120 metres lower than they are today. And the rest of Europe was either covered by tundra-like conditions or cold weather forests and steppe-like forests. And the movement of the ice drove humans. Early humans were not able to live on that ice, but they were able to live on the tundra-like conditions further south. So as the ice came and went, the early human populations migrated north and south, depending on where the ice was. And across the tundra wandered these enormous Ice Age animals, such as the mammoths and the woolly rhinos, saber-toothed tigers, and reindeer and other sort of elk-like creatures. They also did not wander over the ice itself. Nothing really could exist on the ice. So they all wandered across, and they were freely wandering all the way across Europe, across into the UK, and out again, depending on where that ice was. And we found evidence of fossilized rhinos here. This one is about 42,000 years ago. It was found a few years ago and caused great excitement. Particularly because it wasn't the only one found in that site. There were about 4 rhinos, a couple of reindeer, a couple of mammoths, and so they've been able to date those bones, and they were obviously living in the British Isles, at 42,000 years ago, probably during an interglacial phase where the ice was a bit further north. And there's a dig showing some lovely mammoth tusks and mammoth teeth. And mammoth teeth are found in many areas of southern England now in gravels. If you live anywhere near a gravel pit, a lot of those gravel pits are derived gravels that have come out of glacial material during the Ice Age. They've been washed out, and now they form collections of gravel, which we can now dig out for the purposes that we use gravel today. And you often do find bits of mammoth teeth. If you've got large bits of gravel, you sometimes find the odd fragment of a mammoth tooth, which is very similar to a modern elephant's tooth. They have a very distinctive structure, and the teeth grow in vertical plates. As the animal grows, the teeth get bigger and bigger and bigger. And even in the North Sea, when material's been dredged up from the sea floor of the North Sea, we found mammal remains at the bottom of the North Sea, which indicates that way back in time, those animals were able to wander right across what is now the North Sea. So during times when Britain was still joined to Europe. And that's a fantastic skull of a woolly mammoth that was actually dredged up by a fishing boat in the North Sea. So if we look at the map of Britain joined to Europe about 800,000 years ago during one of these interglacials, there was freedom of movement of humans and animals across from Europe backwards and forwards, migrating according to the temperature. And during that time, this is a map showing that situation. During that time, about 800,000 years ago, the Rhine River actually drained into the North Sea, and the Thames drained not into the Thames estuary of today, it drained across the area now covered by the Wash, and it drained into the North Sea. And Britain was joined to Europe particularly by a structure called the Weald Artois Ridge. It was a ridge of chalk, which I'm going to talk about in a minute. But the significant thing is that the Thames drained northwards. There it is, there. And during that time, about 800,000 years ago, along the banks of the River Thames, there were very primitive sort of Paleolithic communities that lived in the mud flats, living on animals, deer, oysters, seafood, and things like that. Now, how do we know that? Because they found some footprints of these people. Now, these footprints were found in Haysborough in Norfolk at low tide. They look like modern footprints in soft mud, except they're not in soft mud. That is actually very hard, consolidated mud that was only exposed after a storm when all the soft modern muds were washed off. And they found these footprints, which they've dated, because of what was overlying them, they've dated them to about 800,000 years ago. So there's no evidence, we've got no skeletal remains of those people, but we have got what are called trace fossils, that is their footprints. And they've also found modern sort of flint axes as well. And this is a map showing the distribution of Stone Age or Paleolithic artifacts like axes and arrowheads and things like that. And from the dots you can see that most of those artifacts are concentrated down in the south, or certainly in East Anglia. They don't extend up into Scotland or into Wales very much. So very much these Paleolithic people lived on the edges of the ice sheets, not on the ice sheets. And the first actual fossil evidence of humans, fossil human evidence, is this Boxgrove man. Well, he's called Boxgrove man, but he could have been a woman. But all they found of him was 2 bits of shin bone and 2 teeth. So that doesn't actually tell us very much. But they were able to work out that he was about 5'11", weighed about 14 stone. So it's probably likely to have been a man, but it could have been a woman. And the significance of Boxgrove man, that site in Boxgrove in Sussex, is that as well as that, those very small amount of human remains, they found a lot of animal remains and a lot of Paleolithic hand axes. And so from what they found, the bones that they found and the way that the bones had been split, they had actually been broken up manually by these people, they have surmised that it was some sort of butchery ground, or where they collected and butchered a lot of animals like reindeer, and they could see the way that they were cut. They were after the bone marrow. They actually extracted the bone marrow. And here on the left-hand side is an example of a reindeer bone that's actually got cut marks on it. Cut marks made by stone axes such as these. These were all found at that Boxgrove site. And I mentioned this wheeled artois ridge, which was a chalk ridge that stretched all the way from what is now the North and South Downs, all the way across to France. And if you go to Calais, you can see the chalk cliffs. There you are. So these are the remnants of that ridge. It's been eroded away to form the channel, and I'm going to tell you a little bit about that in a minute. But Beachy Head, you can date the rocks at Beachy Head, and they can be matched up with similar features in France. And so the whole thing was once joined together. But 450,000 years ago, so we're coming forward in time now. 450,000 years ago, if you remember, I said that was the Anglian glaciation. The big ice sheet had come down. It covered most of Scotland and East Anglia. And there was ahead of that ice sheet, there was a big glacial lake that covered most of the North Sea. The waters in the lake came from the rivers of Europe that were flowing northwards into that lake, and the Thames was also flowing into that lake. The Thames had been pushed slightly southward by the ice, and at the top, the northern side of the lake, that was confined by the ice, and the southern part of the lake was confined by that wheeled Artois ridge. So it was actually trapped. The water was trapped in that area. And meanwhile, there were rivers flowing down from Europe. The Seine and the Somme and the Solent were flowing into the land which became the channel. We're talking about here, the channel hadn't yet formed. The English Channel hadn't formed yet. This was land. Very, very low lying, but it was land. And so there we are. That's what constrained the position of the lake. And we see this sort of thing in modern day places where there's a lot of ice. This is Greenland, and this is an ice-dammed lake. The ice is over to the left there, and then there's moraine on this side, and in the middle there's some water that's collected. It's been trapped there until such time as the ice melts or the water builds up and it can overflow overflow out of that little river channel there. And sometimes this happens in Iceland. Quite often it happens in Iceland. And a glacial lake will suddenly overflow, forms a flood. Sometimes these are quite dangerous. And this is a reconstruction of what they believe happened just about 450,000 years ago when that glacial lake that was in the North Sea overflowed. It built up and up and up because, if you remember, I said all the rivers were flowing into that lake. The level of the lake got higher and higher and higher, and eventually the lake overflowed. And it overflowed over that wheeled Artois Ridge into an enormous cascade and broke through, if you like. It broke through and eroded that ridge away. And that was the beginnings of the English Channel. And if we look at an aerial view, satellite view of the Straits of Dover, the blue, you can see that channel, deep, an area of much deeper water, flowing through the centre of the Straits of Dover. And when the British Geological Survey have done surveys of the floor of the channel, you can see the channels there, the deep channels that were carved away by that overflow towards the end of the Anglian glaciation. And further downstream, the left-hand picture, that channel, that deep channel, is right up at the top, the dark blue area right up at the top of the picture. But further downstream, there are these funny structures which look like what are known as braided rivers with little islands in between them. And we can see the exact same thing today happening here in Iceland. So that's how geologists know a lot about what happened in the past. We're able to observe what things are going on today and sort of trace them back and find those structures, that evidence of similar activity way back in geological time. Now, 235,000 years ago, it was in the middle of an interglacial. It was a period when there was no ice over Britain, and it was quite warm, and species were able to migrate again across the Thames, where the Thames is now diverted to its current position. So if you remember, I told you that the ice eventually pushed the flow of the Thames southwards so that it now occupies its present position. And this was probably the first time that Britain became an island, but only temporarily, because it became an island because most of that ice had melted, and so the sea level rose again. But of course, we know that we then had another ice age, and when you have an ice age, the sea level retreats. So there's the Thames flowing in its current position. And during that time, it was, as I said, it was a warm period. It was an interglacial. And so warm species from North Africa and southern Europe were able to migrate across. There was nothing to stop them, and they were actually encouraged because there was no ice. So they moved further north to perhaps better feeding grounds. And so we find, this is a little picture that shows it's got Trafalgar Square in the background with animals such as leopards, elephants, modern elephants, hippos, warm-loving creatures. Those fossils of those creatures were found in Trafalgar Square when they were doing some excavation works for new buildings. So we know that there were, during the time of the interglacials, it was warm enough to support those sorts of creatures. But then, during the last glaciation, the Devensian ice sheet, you can see the ice coming down there from north. That's as far as it came down. It didn't go into southern England, but the ice pushed some of the rivers. The rivers started to flow, particularly the European rivers, flowed into what was going to become the Channel. And to the north of those rivers, there was an area known as Doggerland. You may have actually heard of Doggerland. It's actually where modern-day Dogger Bank is now found. And it was an area of low-lying plains with little rivers and streams flowing across it at the edge of the ice sheet. There it is there. And it probably looked something like this. Very low-lying, lots of water, marshy land, but it was quite conducive to habitation. And early Mesolithic Bronze Age people lived on Doggerland. It was very fertile. There was lots of fish and trees and other vegetation on which they could build their houses, their huts, and also their crops. But as the ice continued to melt, sea level rose, and Doggerland was becoming increasingly flooded. And so that forced the people that lived there to move to higher ground into Britain. There's Doggerland as it is today. And it's got some wind farms on it, a large wind farm now on it. But another effect of the ice melting is that when you have a big layer of ice, it presses the crust down. As the ice melts, the crust rebounds like a cork bobbing up in water. And what we get is known as glacial rebound. So Scotland is now rising about up to 1 centimetre a year, because that's where most of the ice was concentrated. And this is another map showing something similar, but it's also showing that the areas in the south, those maroon areas, they are sinking. So Scotland is rising, and southern Britain is sinking. Fairly slowly, 1 millimetre, 2 millimetres a year, but it is sinking. So in Scotland, you get raised beaches where the land has come up. There's a raised beach with caves. That's an old sea cliff that's now well above sea level. And in the south, such as we've been on this cruise, we see drowned valleys. So when we were in Falmouth and the Helford Estuary, they were drowned river valleys because the land is sinking. Even yesterday, we saw in the Scilly Isles, if you went on a tour, they probably told you that Scilly Isles used to be one big mass, as there on the right-hand side. Now, because the sea level has come up, that mass has been flooded, and all we get is these lovely little individual islets. And the sinking land, of course, in South Wales, you get submerged forests. Now, this is more or less my last slide. The question is, what's happening now? I said we were in the middle of an interglacial. The red circle indicates where we are now. We are actually in a warm phase. We don't know yet when that warm phase is going to end. And we also have all this talk about about global warming. Are humans affecting the climate, the modern day climate? Well, it's a very thorny issue. There's lots of evidence for and against, but overall the general opinion is yes, we are affecting the climate. It will continue, it could continue to get warmer, but we could also get colder. We could go back into another glaciation. At some stage we won't be around to see it. It could be thousands of years. But since the Industrial Revolution, there is evidence that the amount of carbon dioxide that's gone into the atmosphere, it also coincides with a sudden increase in temperatures, much greater increases than we've experienced up to now. So this is a map of the flood risk of the Thames. This is what would happen if the sea level continued to rise. The Thames barriers, they, to a certain extent, help against flood surges and things like that, but they won't be sufficient to hold back an enormous rise in sea level. And as my last slide, just as a sort of depressing thought, this is what the British Isles would look like if all the ice sheets, the land ice, were to melt. And so the sea level, if all that ice melted, the sea level would go up 70 metres, and so this is what it would look like. But as I said, we're talking thousands of years, but we can at least prepare for slight rises, because by the time it gets to this phase, we'll be long gone, and hopefully most of our descendants will be long gone. But it's a sobering thought. So thank you very much for listening, and I've enjoyed talking to you, and I hope to see you again. If you're staying on for the next cruise, I will be on for the next cruise as well. But if not, thank you for coming, and hope you've enjoyed it. Thank you.